Hello everyone. So we have a question from NEET 2025. Consider the following compounds KO2, H2O2 and H2SO4. The oxidation state of the underlined elements in them are respectively. Okay. So we have to find out the oxidation state of K in KO2, O in H2O2, S in H2SO4. Okay. So the chapters involved is redox reaction and chemical bonding. Okay. So in KO2, so let's first talk about KO2. We might be tempted to assume that the oxidation state of O here is -2 and assume the oxidation state of K as X and then proceed as follows. So we assume it as X and then we say that oxygen is in the -2 state. So therefore X plus 2, and since there are two atoms of oxygen each carrying oxidation state of -2, so total charge is 0. So therefore X will be equal to +4. So therefore the oxidation state of K is +4. Okay. This is incorrect because according to the rules for assigning oxidation number, the oxidation number of alkali metals, that is the group 1 metals, lithium, sodium, potassium, rubidium, cesium, all of them is always 1. Okay, so I will write this point down. The oxidation number of alkali metals, that is the group 1, is always +1. So where did we go wrong? Okay, so our assumption that the oxidation state of O is -2. Remember, we assume that it is -2. This is incorrect because it is not necessary. Okay, in case of oxides, it is true. Okay, whenever we have oxides, then the oxidation number of oxygen is -2. That is correct. Okay, but we have been given KO2 and it is potassium superoxide. It's an ionic compound and we know according to rules. Okay, so it's an ionic compound. That's a very important point. And according to the rules, we know that oxidation number of a monoatomic ion is the same as the charge on it. Okay, so I will write this down. Oxidation number of a monoatomic ion is the same as the charge on it, right? So since we mentioned that KO2 is an ionic compound, so therefore we can say that KO2 consists of, so this guy KO2 consists of obviously K plus ions and O2 minus ion because overall it is neutral, right? So oxidation number of K will be obviously 1 because we have mentioned that oxidation number of a monoatomic ion is the same as the charge on it. So potassium exists as K plus, so its oxidation number will be +1. And if you want to calculate for oxygen, assume that it is X. So there are two such atoms of oxygen, so it will be 2x equal to the charge -1. So X will be equal to -1 by 2. So therefore, for one oxygen atom, the oxidation number is -1 by 2. You can see here. Therefore, it is not true that the oxidation number of oxygen is always -2. Okay. For superoxides, it is -1 by 2. Cool. Then we have H2O2. Okay. So we know that according to rules, oxidation number of hydrogen is +1 when combined with nonmetals. Okay, so I will write this down. Oxidation number of hydrogen is +1 when it combines or when it is combined with nonmetals, and it is -1 when combined with active metals. Okay, and it is -1 when combined with active metals. So in our case, you can see oxygen is a non-metal, so therefore hydrogen is combined with oxygen, which is a non-metal. So therefore the oxidation number of H is going to be +1. Okay. So in our case, the oxidation number of H is going to be +1. and we have to calculate the oxidation number of O in H2O2. Okay, so in H2O2 we have to calculate it for the O. For hydrogen we know it is already +1, so there are two such hydrogen atoms, so 2 into +1. And let us say for O it is X, so X into 2 will be equal to 0. Overall charge is 0, so 2x will be equal to -2 and x will be equal to -1, right? So oxidation number of O in H2O2 is -1. Okay, again it is not -2. Okay, because as I mentioned, -2 is only for oxides. Okay, H2O2 is hydrogen peroxide, so this guy is hydrogen peroxide. Okay, so therefore be careful, and it is quite helpful to know the names of the compounds, right? Because if you know that it is a peroxide, the oxidation state, you know it is -1. If you know it is superoxide, you know the oxidation state is going to be -1/2. Okay, so whenever you hear the name peroxide, they will always contain two oxygen atom. So peroxides will always contain two oxygen atom linked by a single bond with an oxidation state of -1 per oxygen atom. With oxidation state of -1 per oxygen atom. Okay, so therefore you know H2O2 will look something like this. Since it is peroxide, so it will have a OO single bond linkage and H attached to it. Okay, so this is the story for H2O2. Next we have to talk about H2SO4, third one. Okay, so in H2SO4 we have to calculate for S. Okay, so if you have studied a bit of chemical bonding, we can draw the structure of H2SO4, the Lewis dot structure, and it looks something like this. Even if you don't know the structure, then also we can calculate the oxidation state, but I wanted to show you something. Okay, so in the structure of H2SO4, it is evident that the oxidation state of oxygen is -2. Okay, because all of these oxygens are in the oxide form. Okay, so all the oxygen in H2SO4 are in oxide form. Now when I say oxide form, I mean single O atom with oxidation state of -2. Single O atom with oxidation state of -2. So you can see on each individual oxygen, this oxygen, it is more electronegative than sulfur, so therefore it will have a -2 charge because there is a double bond. This oxygen will have a -2 charge because it is more electronegative than sulfur, right? This oxygen will have -1 from here and -1 from here, again -2 charge total. This oxygen also -1 and -1, -2 charge. So all these oxygens are in the oxide state. Okay, so now we can proceed with our assumption that okay, here oxygen this time it will be -2. So hydrogen as usual, it is combined with non-metals like sulfur and oxygen, so it is going to be +1. So therefore 2 into +1 plus sulfur we don't know, plus 4 into -2, because this time all the oxygens are in the oxide form, it will be equal to 0. So x will come out to be 8 minus 2 is equal to 6, right? So therefore this is the oxidation state of sulfur. One more thing, you can also calculate the oxidation state of sulfur from the structure, right? How? So here oxygen it is -2, so therefore sulfur will be +2. Because of O1 there is a +2 here. Because of O2 there is a +1 because it pulls one electron towards itself. Because of O3 there is a +2. Because of O4 there is a +1. So what is the total positive charge? 2, 3, 4, 5, 6. So therefore it is +6. From the structure also you can say that. Okay, so therefore we have calculated um, for K it is +1. For O in H2O2 it is -1, and for S in H2SO4 it is +6. Okay, so therefore C is the correct answer. Okay, thank you.